Alright, let's have a look at a closer look at gravitational potential energy. We spend a bit of time with it and we see how it changes, and it can change into kinetic energy. And we've noticed this with our calculations. We're assuming that there is 100% transfer between gravitational and kinetic. As we see with our rider here, he starts off and goes higher in the air. The higher he gets, the greater will be his GPE. But it also means that he has more energy he has to navigate and try to overcome when he lands back on the ramp. So it's a bit of a worry. Alright, our potential energy in this case is gained by being higher off the ground, or altitude. Alright, so the higher we are, the greater the effect. Gravity is a big factor in gravitational potential energy, hence the naming. Alright, so any object that is raised off the ground has its gravitational potential energy increased. Now the further we raise it, the greater the increase. When we're doing this, we ask you to calculate. Now calculations are based upon these, and I'm going to put a few little additions in on the side. I think I'll do them in red today. Now this is going to be in GPE, is going to be in joules. The mass must be in kilograms. And this is what we're relying upon you remembering as you go through and do these calculations. That the units must be observed before we start. Right, G is not grams in this case. G is the gravitational effect of the Earth. And we're going to call it a constant. And we're going to use that as our value. Right, you might notice that there are different units that people use as we go in various books and things like that. So you might find these as you go into various websites and goodness knows what. So please be mindful of that. Now, here, and it's going to be a vertical distance. Not an angled distance, but it should be a straight vertical distance, and it's measured in meters. Now if we follow all these things, then when we multiply them all together, it all makes sense. And our GP will come in terms of joules. So please make sure you put those in. Quite an easy calculation, and so we can ask you things like, how much will it increase by if I do something? And I think our next example actually proves that. Right, so let's look at the example we've got here. We're lifting a book off the floor and putting it on a table. We've said the book has a mass of 200 grams, right? And the table is 1 metre high. Now gravity is always going to be 9.8. So if I'm doing this, I can put the things over the side. If I'm doing this, I can put the things over the side, and I can have what the thing tells us, what the question tells us, and then we can work from there. So we've got a mass of 200 grams, which is equal to 200 divided by 1,000 kilograms, or 0.2 kilograms. I've got G is always 9.8. I'm not going to worry about putting the units in. And the height, or vertical distance, D, is going to be 1 metre. So I've got my mass in its correct forms in kilograms. That's where this number comes from. I've got my G value here, and 1 metre is there. So when I do all these sort of things, I find that my value is 1.96 joules. So that's about how hard it gets. It's not very hard, some of these questions, but we will be giving you lots of them in the test.